For this lesson today, we are going to be discussing domestic hot water heaters, how to size them, what's involved with the distribution of hot water through a home or a business. If we really think about domestic hot water, it's found everywhere. There is not a single restaurant, home that does not have some sort of domestic hot water availability. So when we are looking at domestic hot water, one thing is that we, as a design mechanic or even a service mechanic, we sometimes might run into a situation where the hot water may not be enough. An example of that would be, I got 4 people living in the house, and usually by the time the 4th person gets into the shower, there's no more hot water left. That can be an issue with homeowners, manufacturing, hotels. For example, we got to always make sure that we have the correct amount and enough hot water for a business to use that water for, processing, or, for, hotels and motels. We got to be able to have enough hot water to be supplied to each one of the rooms. So when we are talking about hot water and sizing, we got to think about our sizing in GPMs. It's flow rate, gallons per minute. Okay, that is based on input of building types. It's based on your fixture types, and it's fixed on the amount of quantities. Okay, so we have to assume and look at the overall picture of that building or home. Okay, how many fixtures do they have in the house? How many bathrooms? How many sinks? How many showers do we have? We have to take into account the number of people that are in that space. Example of like even a hotel. We got to know the maximum amount of people that will be in this facility. For homes, obviously, we got to know the number of occupants in the home, 3, 4, 5, 6 people, whatever it is. Okay, so think about where domestic hot water is found. Obviously, bathtubs, showers, your tubs and showers, jacuzzi tubs, kitchen sinks, lavatories for all of your public buildings, right? Clothes washers. Dishwashers and hot water hose stations for your commercial, industrial, manufacturing type buildings where we're using the hot water for manufacturing. So sizing a hot water heater for proper gallons per hour, that is one of the things that really in some cases can get messed up. A lot of stuff when it comes to this is math. You mess up one formula or one calculation, it throws the entire operation right off. So a properly sized water heater will meet your household's hot water needs while operating more efficiently. So therefore, before purchasing a hot water heater, we have to make sure that it is the correct size. This guy here is an example of an on-demand water heater. These are very, very common in a lot of homes. They are sometimes common in commercial and industrial type applications. But you will definitely be seeing more and more of these as they come out. They use pretty much very little water. As you could kind of see, it's not really that big in size. They usually mount right on a wall, so they don't take up a lot of floor space. But these is the new types of technologies that we're having out here. This particular one here, this is a gas fired, high efficiency, on-demand water heater. So your tankless or demand type water heaters are rated by the maximum temperature rise possible at a given flow rate. So when we are sizing a demand water heater, you need to determine the flow rate and the temperature rise you'll need for a specific application. Okay, for example, like a whole house or a remote application, such as like a bathroom. Okay, maybe we're just using that water heater to supply the hot water for the entire house. Or maybe we're using that water heater just to supply hot water to one single bathroom in the home. Okay, the same can apply to businesses. We can use that water heater to supply hot water through the entire building, or maybe just for one specific bathroom in the building. Okay, so there's a lot of things that come into play, again, as we are servicing and putting in some of this equipment. So first, when it comes to any time we're sizing a piece of equipment, list the number of hot water devices you expect to use at any one time. In HVAC, this does not necessarily only apply to hot water heating. This applies to your gas heat, your oil heat, air conditioning, so on and so forth. When we are sizing our HVAC equipment, we are always sizing it for the maximum amount that that unit will be utilized for. And what I mean by that is if we are having all of our equipment on at the exact same time. So for example, here we're talking about hot water. We are going to size that hot water heater for every hot water faucet in the building to be on at the exact same time to give the same amount of hot water at a given rate. Okay, so for example here, let's say you expect to simultaneously run a hot water faucet with a flow rate of 0.75 gallons per minute and a shower head at a flow rate of 2.5 gallons per minute. Those two areas are going to be on at the exact same time. So I got to be able to have a hot water heater deliver the same temperature water to both of those appliances at the exact same time with little to no loss of temperature. The flow rate through the demand water heater would need to be at least 3.25 gallons per minute. Okay, to reduce the flow rate, you are going to install a low flow water fixture. And in an HVAC world, we are pretty much, little parts of every single trade that's out there. I mean, we are carpenters, we're masons, we're electricians, we're plumbers. So when it comes to hot water design and availability, we got to utilize a lot of knowledge to make things work in an efficient manner. Okay, now it says here to use to install a flow rate or have a low flow water fixture. Well, reason why we're doing that is because obviously we're going to be dumping 3.25 gallons per minute out of those two faucets. That's a lot of water. So what are we going to do to help a business owner, homeowner, have hot water but not blow up their water bill? We can install low flow water fixtures where they regulate the amount of water through there, almost kind of like a nozzle or an orifice in a gas furnace. The same type of concept. Okay? To determine temperature rise, we're going to subtract the incoming water temperature from the desired output temperature. Okay, so for example, we have 50-degree water coming in. Okay, and we want that water to be heated to 120 degrees. Okay, in this example, you'll need to determine your water heater that produces a temperature rise of at least 70 degrees for most uses. Granted, there are water heaters out there that have higher temperature rises, but again, we have to utilize and know what we are dealing with. Okay, for dishwashers without internal heaters or other such appliances, you might want to have a water heater heat the water up to about maybe 140 degrees. Okay, and in that case, you're going to have a temperature rise of 90 degrees. So water heat is a regulation. We have to be able to regulate and control the temperature of the water coming out of our faucets. Because one of the things that we want to try to avoid in HVAC is scalding. We don't want somebody to turn on their hot water and then get burned. So we want to have a water heater that is in our home or place of business that's going to deliver the correct amount of hot water, but it's going to be at the correct temperature. Anything other than that, we're going to have problems. Okay? Most demand hot water heaters are rated at a variety of inlet temperatures. Okay? Different manufacturers, different sizes, so on and so forth. Not everything is always the same. We have a variety of types of different manufactured water heaters that are out there. We have oil-fired water heaters. We have gas-fired water heaters. We have electric water heaters. We have on-demand water heaters. Okay, so typically a 70-degree water temperature rise is possible at a flow rate of about 5 gallons per minute through gas-fired demand water heaters and 2 gallons per minute through your electric ones. Okay, now why is there such a difference in the size or the amount of gallons per hour based off of what type of heat source we're dealing with? Well, natural gas heats up water at a faster rate. So I can push more water through a gas-fired water heater versus in an electric water heater. Okay, an electric water heater is nothing more than electric heat elements that are inserted into the well where the water sits. If I'm moving too much water too fast across those heat coils, I'm not going to be able to deliver the correct amount of heat and the correct amount of water temperature to my faucets and my appliances in an efficient amount of time. In order for an electric heater or electric water heater to really kind of reach temperature in an efficient amount of time, is all the faucets and everything has to be shut off. There can't be no water movement. Now with a natural gas or even an oil-fired water heater, I'm dumping 140,000 BTUs into that heater once my burner turns on. I can heat up my water a lot faster. So my flow rates and my gallons per hour, gallons per minute, are going to vary based off of my type of water heater that I'm installing. Okay, faster flow rates or cooler inlet temperatures can sometimes reduce the water temperature at the most distant faucet. Okay, so some types of tankless water heaters are thermostatically controlled, and they can vary their output temperature according to the water flow rate and the input temperature, which is another reason why we are going more towards your on-demand water heaters. On-demand water heaters, they take into account the amount of water flow, so to speak, that's going through that piece of equipment. If I have multiple faucets open, someone's taking a shower, someone's washing their hands, or something going on, that on-demand water heater can now ramp up or ramp down either my heating element or my flow rate through that water heater, so that I can now still efficiently heat my water and deliver it to where it needs to be. So sizing storage and heat pumps, heat pump water heaters. To properly size a storage water heater for your home, including a heat pump water heater with a tank, use the water heater's first hour rating. The first hour rating is the number of gallons of hot water the heater can supply per hour, starting with a tank full of hot water. It depends on the tank capacity, it depends on the heat source, and it depends on the size of the burners or elements. That is what's going to determine what my first hour rating of number of gallons of hot water that this hot water heater is actually going to be able to deliver. Okay, product literature from the manufacturer may also provide that first hour rating. So look for hot water models with a first hour rating that matches within 1 or 2 gallons of your peak hour demand. Okay, to the daily peak 1 hour hot water demand for your home or your place of business. Okay, so what are we thinking about when we're talking about the peak hour of demand? When is that going to be in a home? That's probably going to be in the morning, right? Or maybe even at night when that person's coming home from work or getting up to go to work. They're going to get up. They're going to take a shower. Okay, kids are going to be getting up. They're going to want to be taking a shower, hopefully. Or vice versa. They come home and they're coming home from a long day's work or from school. They're going to get into that shower. They're going to use all the hot water at that point. So we're going to size a hot water heater to handle or match that peak hour rating or that first hour rating that we calculated for. Okay, to estimate your peak hour demand, the thing that you got to do is first you got to determine the time of day, morning, noon, evening, like I just said. You use the most hot water in your home, so keep in mind the number of people that are living there. Okay, use the worksheet on the next slide to estimate your maximum usage of hot water during this 1 hour of the day. This is your peak hour demand. So note, okay, when we're going to go through this, the worksheet does not estimate total daily usage. Okay, so here we are. This is a nice little sheet right here. So what we do is we can utilize, we take the number of showers that we have, say in this case we have 10. We're going to multiply it. You can't really see it on this slide, and I do apologize for that. You're going to multiply it by the number of people that are in the home. Okay, so we got 10, say this is 10 gallons. We have, say, 4 people. Okay, so we're going to have about 40 gallons of water that we're going to have to heat up. The same would apply for your hand dishwashing, and if this is obviously like, a restaurant or so on and so forth, you would just do the same thing. Clothes dryers, whatever it is, you have to take all of your appliances, all of your people that are in that home business, and do some simple multiplication to figure out what your whole heating demand is going to be. Okay, peak demand example. Okay, so guy's shaving, one shave. Okay, he's probably going to use around 2 gallons of water. Okay, times that one person, you're going to use roughly, maybe 36 gallons of hot water for that, old man to shave his beard. Okay, conventional storage water heaters remain the most popular type of water heating system in the home. Okay, the big old cylinder guys that are sitting on the floor in the basement. Now we will find out some basic information on how storage water heaters work, what criteria to use when selecting that type of model, which one's going to work the best for you, and some installation, maintenance, and safety tips. Okay, single-family storage water heaters offer a ready reservoir of hot water. Okay, so think about it. They usually come around and hold somewhere around 20 to about 80 gallons of hot water. Okay, apartments may have slightly, smaller sized water heaters. Condos, same thing. But homes, you're probably talking around the upper end of probably about 80 gallons of water sitting inside your water heater. It operates by releasing hot water from the top of the tank when you turn on the hot water tap. Okay, to replace that hot water, cold water enters the bottom of the tank and ensures that the tank is always full. Conventional storage water heaters, fuel sources include natural gas, propane, oil, and obviously your electric type. Since water is constantly heated in the tank, energy can be wasted even when a hot water tap isn't running. Again, what we call this is called by standby heat loss. One way to eliminate and to kind of minimize your standby heat loss is actually a good idea to insulate your hot water pipe that's coming out of your water heater. By adding a little bit of insulation, just take some pipe insulation and wrap it around your hot water pipes, eliminates and lowers the ability of that pipe to lose its heat to the surrounding air. Now think about where most of your water heaters are located. Probably in a home, they're going to be in a basement. Okay? Sometimes, most likely, probably right next to the boiler, especially if it's an indirect. If that water heater and those hot water pipes are in an environment of 40, 50 degrees, we know the laws of thermodynamics that, heat will always go from hot to cold. Those pipes are going to lose some of their heat. And when that pipe loses that heat, that water heater is now going to have to turn back on and add that heat back into those pipes. So to minimize that, trick is to actually insulate those pipes to try to create a barrier. Okay, some storage water heater models have heavy insulated tanks, which significantly will also reduce your standby heat loss and lower your annual operating costs. Okay, so what we want to do is we want to look for models with tanks that have a thermal resistance or R value of R12 to R25. When you are at even Home Depot and you are purchasing a water heater, look at the R value. Look at the jacket rating on the water heaters. The higher the R value, the more insulation is actually wrapped around that water heater. Okay? So what you want to do is obviously the more insulation, the lesser that model of water heater will have the ability to actually lose any sort of heat that has been generated. Okay? Just a little tech tip for a lot of people. Okay, here's a typical gas water heater. Okay, so down here is our burner. Just again, you can almost think of like a water heater, like a pot of water on a stove. Okay, here's my burner, which is down here. This up here would be all filled with water. But notice the flue pipe on a gas water here sticks right through the center. Oh, look at that. Cold water is coming in, which is going to fill up my water heater from the bottom up. And when I open up my tap, that hot water is now going to come back out. So what's nice about your gas water heaters is that we are actually using the flue pipe to heat up our water. Not only the burner, but also the flue pipe. Okay? The jacket, which is right here, is our insulation, is what actually keeps that water heater all nice and warm. Okay, so the thicker the R value on our insulation and on that jacket, the better efficient your water heater actually is. Okay, gas and oil water heaters also have venting related energy losses. You have two types of water heaters, a fan assisted gas water heater and an atmospheric sealed combustion water heater. Okay, reduces these losses. Okay, the lowest price storage water heater may be the most expensive to operate and maintain over its lifetime, while an oversized unit may be might be a little bit much and can carry a higher purchase price and increase energy costs due to higher standby energy loss. So what we're saying is sometimes you may not necessarily want to go for that higher end water heater. Sometimes oversizing it, you're just kind of wasting energy. Okay, so we want to make sure that we get something that works best, but not obviously break the bank. Before buying a new water heater, you want to consider the following. Okay, the size and again the first hour rating at which that water heater is going to be worked. Remember, day, morning, afternoon, evening. When is that first hour rating highest peak going to be? Your fuel type, is it gas, is it oil, is it electric, is it propane? Okay? And obviously the availability of those heat sources. Okay? Obviously if you don't have an oil tank or oil fired, boiler or furnace, you're not going to want to install an oil fired water heater. It just doesn't make any sense. If you have natural gas in your home, you might want to maybe install a natural gas water heater. You have the heat source. Okay? Obviously, energy efficiency and obviously cost. Okay, periodic water maintenance can significantly extend the water heater's life and minimize loss of efficiency. When you're doing this, you're going to want to read the owner's manual for specific maintenance recommendations. Okay, routine maintenance for your storage water heaters depends on what type and the model you have. Okay, some routine maintenances actually will require you to flush at least a quart of water from the storage tank every 3 months. You're going to want to check the temperature and pressure valve every 6 months. Again, this all depends on the model of your water heater. Okay, inspecting the anode rod every 3 or 4 months in a water heater. Okay, an anode rod is what actually takes out any sort of impurities in the water. Okay, calcium, iron, stuff like that. The anode rod will actually catch all of that impurities. If we have high concentrations of like calcium and iron in our water, we actually can deteriorate the metal in the construction of the water heater. So every once in a while you're going to want to maybe do that. Okay, mixing valves. Your thermostatic mixing valves are better known as TMVs. These are actually what controls the water temperature for bathing, showering, hand washings, and all that other stuff. Okay, they are designed to maintain a desired water temperature even when the incoming water pressure or flow rate actually changes. Okay, so by contrast, the mechanical mixing valve cannot adjust the change in supply temperature, pressure, or flow rate. And that's what they would actually look like. So to adjust your flow rates, obviously you would just simply turn your handles. Opening and closing them is obviously going to restrict the flow of water, or opening them is going to increase your flows across your water heater. Okay, this is a tankless water coil that you will actually sometimes find. Sometimes these are mounted right inside a boiler. So you would have cold water coming in through the top. This would be sitting inside a boiler, and the water would be flowing through this nice little coil and then back out. Okay, usually when we run into these things don't hold any more than maybe 3, maybe 4 gallons of water at a time. So these are more susceptible to quicker loss of hot water versus a standalone or maybe even a indirect water heater, where they would have, like, again, 80 gallons of water sitting in there. Okay, tankless water coils provide hot water on demand without a tank, and when a hot water faucet is turned on, water is heated as it flows through the heating coil or heat exchanger installed in the main furnace or boiler. Tankless water coil heaters are most efficient during cold months when the heating system is used regularly, but can be an inefficient choice for many homes, especially for those in warmer climates. Okay, your tankless water coils were designed to use in hydronic boilers so that you only needed one source to heat your house and get hot water. They did work for many years, but then with the rise in fuel prices and larger homes, they're not necessarily the best way to go anymore. They are still used today in some cases, but not 100%. Obviously, we have more high-efficient wall-hung units where we can push and pull and do different things with your water heaters based off of the demand in the house. If you had a well water, the chemistry of the water would and obviously could plug up the inside of the coil over time. Again, hard water was one of the biggest culprits with these old types of water coils. If you had a lot of calcium buildup, eventually the coil would literally just plug up and you would have absolutely no hot water whatsoever. In order to get it, you would have to replace the coil. But today, we go towards this, your indirect water heaters, where we're actually using the boiler and hot water as a separate zone of heating. Okay, indirect water heaters are a more efficient choice for most homes, even though they require a storage tank. Okay, an indirect water heater uses the main furnace or boiler to heat a fluid that circulates through a heat exchanger in the storage tank. The energy stored in the water tank allows the furnace to turn off and on less often, which will obviously have energy savings. An indirect water heater, if used with a high-efficiency boiler and a well-insulated tank, can be the least expensive means of providing hot water, particularly if the heat source boiler is set for a cold start. Okay, indirect systems can be fired by gas, oil, propane, electric. We can use solar energy or a combination of any one of these. So when selecting a system, you need to consider, again, its size. When sizing of a combination system involves some different calculations than those used for sizing a separate water heating or space heating system. It's best left to a obviously qualified heating contractor to do so, because obviously all of your businesses have some sort of program, computer program that we can just punch in the numbers and it gives us what size water heater we need. Okay, here's a couple variations of different types of water heaters that are out there. Okay, or you can have something like this. Okay, does look like a big old mess, but that is an industrial sized or zoned type water heater system. Okay, selecting a new water heater system. So when selecting a new one for your home, choose a water heating system that will not only provide enough hot water, but also that will do so energy efficiently, saving obviously money. This includes considering the different types of water heaters available and determining the right size and fuel source for the home. Okay, your fuel types and its availability in your area may narrow your water heater's choice. The following is a list of water heater options by fuel and energy source. Okay, so obviously we have electric. Those are widely available in the United States. Okay, we also have our conventional storage. We have tankless or demand type. We have heat pump water heaters. It is also can be used in a combination of water and space heating systems, which include tankless coil and indirect water heaters. Okay, we do have some cases where actually a water heater is used for space heating. For example, radiant heat. We can use that as a combination. We can use a water heater for combination of heat and hot water. Again, obviously our fuel oil, okay, available in some areas of the United States to fuel conventional storage water heaters, indirect combination water and space heating. Geothermal energy, again, is available throughout the United States to those who will have or already have a geothermal heat pump system installed in their homes for space heating and cooling. Natural heat gas, again, it's available in many areas of the United States to fuel conventional storage and demand tankless or instantaneous water heaters, as well as combination water and space heating systems, which include tankless coil and indirect hot water heaters. Propane, the same thing. We're using them for tankless, instantaneous water heaters, as well as indirect combination water and space heating systems. Solar energy, available throughout the United States, mostly abundantly in the Southwest, for solar heating systems.